we're here to talk about our cybersecurity data platform at Rivian. So looking forward to share our journey of how we transitioned from a SIEM and lowered our costs for our SIEM by a total of 60%. So while we did that lowering, we also improved our overall capability. So with that, I don't know how many people in the room are familiar with who Rivian is, but I'd like to introduce you to our company. So at Rivian, our mission is really to keep the world adventurous forever. So how do we do that? We are an automotive manufacturer. We produce electrical vehicles. And our commitment is really to reduce the environmental impact of vehicles throughout the world. So we want to offset the world's reliance on ICE vehicles or internal combustion engines. So with that, as you see here, we have 3 great looking vehicles. We have our Rivian commercial van on the left-hand side, our R1S in the middle, as well as the R1T all the way on the right. We have 3 additional vehicles that were recently announced, our R2, R3, and R3X. And that's a little bit about who we are as a company. Now, what I'd like to do is introduce you to our cybersecurity team. So Rivian cybersecurity operations really includes 4 different functions. We have our corporate cybersecurity team, our cybersecurity operations center, followed by our detection and response team, and also our cybersecurity threat intelligence team. Today you have Rob Hartman to my right. He's a cybersecurity engineer that's focused on data and automation. And then I lead our cybersecurity operations team. I've been at Rivian for a total of 3 years. Rob has been on the team for about a total of 1 year. And Rivian's really unique when you look at us from a cybersecurity picture. A lot of people or teams are focused on enterprise cyber, product security, manufacturing, as well as software and potentially retail. Something unique about Rivian is we have a little bit of all that. So when we build our cybersecurity data lake platform, we really need to focus and ensure that our platforms can scale across multiple verticals. So here we're to share our experience of how we got there. We have what we call Trails, which is our threat response analytics and intelligence lake service, which I often forget, fairly large acronym, but we just call it Trails. Here to share our story of how we built Trails, and really want to focus on how we defined ETL, as well as other items with that. So I'll hand it over to Rob to discuss and start running into really actually, I'm going next to talk more about our journey. Sorry about that. All right, so as I mentioned, been at Rivian for a total of 3 years, started back in February 2021. We've had a very interesting data journey. So with that, when I joined, we had 150 gigs of data for our SIEM platform. We quickly increased our scale to about 7 to 10 terabytes of data per day, solely just security and enterprise data. So 3 years, over 30x. With that, we've actually had a lot of SIEM migrations and SIEM transitions that we did to accommodate those changes that we occurred in terms of the volume, but also ensuring we could increase our functionality. With 3 SIEM migrations, it honestly just sucked. And part of it really was an operational burden, but also every year when we did that transition, our costs would follow our ingest patterns and increase 2x every single time, because we went from 150 to over a terabyte to 5 terabytes to 10 terabytes over that period of time. And a lot of the SIEM ingest models are based on total volume. And part of this project, we really want to focus on transitioning from the volume or ingest-based licensing to really how we can really handle that from a compute perspective. So we started our migration, which took really from an initial idea back in October and completed this project in January. So what did that include for completion? Migration of 7 to 10 terabytes of data. Why is it 7 to 10 terabytes? Well, Monday to Friday, when everybody's working, we're at 10 terabytes. On the weekend, we're actually at 7 terabytes. So it transitions and scales, and we have different infrastructure that goes up and goes down depending on our volume and ingest. During the 4-month period of time, we also migrated over 100 data sources. I think we're at a total of 130 data sources today. And then we also migrated over hundreds of detections. So 4 months included, right, our idea, our proof of concept, starting our migration of data, starting migration of detections, completing our migration of data sources, and then finally completing our migration of detection sources by January 20th. With that, now I'll actually hand it over to Rob, and he'll talk about guiding principles for this transition.
Cool. Thanks, Chris. So just to talk through, we took a step back and really evaluated like what we had at Rivian. And we defined some guiding principles that we thought were important to us, really revolving around like our entire platform, data specific, but really taking a look at those fundamentals that Chris talked about in those different departments and all the different data that we deal with. So just to cover those, we aligned with the cost management, data ownership, and then the scalability. So with the cost management, like Chris mentioned, the licensing models continue to increase our costs. So we were looking to ultimately reduce that or just completely eliminate it. And then as well with cost was really just, we want to pay for the compute that we're using and then make sure that we're not paying extra. And that comes across the board, right? Your compute, your storage, being able to have the data for a long period of time and being able to manage it whenever you want. And then that leads into our data ownership. So as we saw moving through multiple different SIEM platforms, some of which like we didn't own the data. So we really took a step back and we wanted to make sure that we manage our own data and we also house our own data. And so we took this approach to make sure that we could set our own SLAs. We're not housing data exterior to our environments, and then we can actually move our data really whenever we want. And then the last piece ties back to cost, but really the scalability. So as Chris mentioned, we do 7 to 10 terabytes per day, and we want to make sure that we optimize the compute, right? On weekends, we may not have as much data, so we can scale down. And then during the week, we need to scale up. And with Databricks, we found all of these opportunities. It met our use case, and we were able to fully scale up and down however we need to meet all of our use cases. So going into the next slide, really looking at like what does Trails look like from a high level. So what you'll see, everything we do, we collect the data in S3. And then we have one large ingest table for all of our data sources. So we do have an upstream data platform that dumps all that data into S3. And then we make sure that we do validations on the schema of the attributes that's coming in. We make sure that we're collecting event timestamps, like from when the event actually happened. And then other additional metadata revolving around the events that we're collecting from any various sources. After the ingest table, we're immediately streaming all of that data out into individual, what we call our refined data sources or our refined source tables. And what these are the true like source of truth tables in which our incident response, our detection engineering, they go to these tables to find the data that they need. We're taking all of that data, and then for all of our detections, detections connect back to our refined source tables, and that moves on to like a little bit more to the right of having our real-time detections and scheduled detections deployed in our environment. So one of the capabilities that we really wanted to move to was the factor of real-time detections. In our previous SIEM platform, we were doing everything schedule-based, and so we really wanted to take it to the next level and be able to immediately alert when that data comes in, when we see it, and then immediately send it downstream to whatever automation and like those kinds of platforms and really send the data where we want it. The last piece on there is our alerts table. So everything our detections capture as an alert is immediately written into our alerts table and then moved downstream. And we'll talk a little bit about the right side of what this picture looks like at the end of the talk. But now I think we'll move it in. And really what we want to do in this presentation is break down each one of those sections for you and then to show you a little bit of what we're doing from an automation and orchestration platform after the data and the alerts go off. So to talk through some of our ingest and ETL, what I'll say, next slide, thanks. This is really like the foundation of our platform. So this is where we're making sure that we have those timestamps. We're collecting the entire event for every single event, and we're making sure that we're doing that validation of whatever we need to do to make sure the event aligns with what we expect coming from the data source. So what we do, we collect all that data as JSON, and we particularly use JSON strings, primarily because of schemas, those kinds of things. We want to make sure that we capture the full raw event. All of that goes into what we call our cybersecurity ingest table. And then that table specifically is partitioned by data source. And you could think of each individual data source then has a corresponding refined source table that we're sending all of that data to. All of the ETL jobs in between our ingest table and the refined source tables, that's where we're manipulating the data, saying, hey, we want to map these JSON fields to these columns. We want to capture the event timestamp and make sure that it shows the full representation of the event. So let's talk a little bit about ETL and normalization. So along this journey, if you work in security, you know that finding the common data model to go for can be a challenge. And in those traditional SIEM platforms, like you do have the ability to search across all your data. And I'll talk about that in a minute, but just to touch on the decisions that we made when we're moving our data to our refined source tables, we chose to normalize all of our data on ECS, which is the Elastic Common Schema. And the reason we chose that was really just the amount of availability, the documentation that's available in the community that surrounds it. And then a couple of other features in which we do, like mentioned, the event timestamp, the date, and then also that raw JSON field. We capture that and move it on every single event. And a couple of reasons for that is that we want to make sure that for auditability purposes, we have the full event. If an upstream data source changes a field name or they add new fields, those kinds of items, we can always roll back, make sure that we're looking at the event, see what they changed, see what they've altered. And if they introduce a completely new schema, we're not missing all of that data that's going across the board. Last thing I'll mention on here, definitely, we found different partitioning practices, but for us, just partitioning on date works the best. And that's for various reasons, really incident response and our detection engineering. When we need to look back at the data in cybersecurity, most of the time we're looking for events that happen within a specific time period. And so what we found is that those dates really, okay, where statement of where date in between these items or where date in the last 30 days. And that really sped up our searching and everything we needed to do across the board. So the last piece, just to talk a little bit about like incident response and threat intel and how we interact with those refined source tables. So it's like, how do you find the data that you need? So moving from a traditional SIEM tool to a more SQL-based or table-based system can definitely be hard. We have indicators that we need to look for across all of our data. We need to like find those items. And now with 100 plus data sources, we have 100 plus tables that we potentially need to search. So the concept here, right, is from a SQL side is a select star from star. And that's relatively easy to do in a traditional SIEM tool. So we've built out practices with notebooks, leveraging Databricks, and our common data model to build out features in which our incident response, our threat intelligence teams, they can search across all of our tables at any given time. So the code snippet you see here is like, we're looking for IP addresses. And we know for a fact that like our source IP is if it's going to be a source IP, it's going to be source underscore IP across all of those tables. And so therefore we can build programmatic notebooks that we're able to look for indicators that we're searching for across all of those tables. And I'll hand it back to Chris to talk through more of our detection engineering.
Yeah, as Rob mentioned, like we built this foundation of how we get our data in, and really that foundation leads us really into what do we do with that data. Detection engineering is one of the many things that we do with that data. And really with detection engineering, our team starts the practice of detection as code. So really our end goal here, when you look at deploying a detection, we want to find bad things that are occurring within our environment and get them into the hands of people that can actually do something about it. People maybe within our team, like the CSOC, or potentially in a cross-functional team, like our networking or identity access management team. Or ideally, in a perfect state, we'd like to automate, based off that standardized data set that we did, a decision that's going to be made to prevent something from spreading or continuously occurring. So with that, we've really broken into 3 categories. That's detection development, as well as testing and deployment. And for detection development, we break our practice into really 2 key tools, right? So we use Jira from a project tracking perspective, followed by Git just from a code management perspective. When we have something come up from a detection, right, in the development stage, it really starts as an idea, which is like that first process within our Jira process. Goes from an idea to being selected for development. After it's selected from development, we start prototyping that idea, designing it within a SQL query, within SQL Workspace. And then once we get that prototype at a point where it's working, we then get into a testing stage or QA stage. So with that, we commit it into our Git repo. We'd merge that into our development instance, deploy it, start measuring data sets based on the actual capability of that specific detection. When it comes to detection testing, we have a couple different detections, some of we've already discussed, but additionally, we want to ensure that the validation occurs as we deploy that within the code pipeline. And in the event that that validation fails, we don't deploy that to our development environment. We don't deploy that to our production environment. So with that, we validate our attributes. We also validate the columns for the detection logic to ensure that those columns exist within the table that we're actually searching. When it comes to detection deployment, you've heard me say Git a few times, but Git is really where we deploy our detections and merge into our production branch. When it hits our production branch, it goes through another set of tests, and any failures that we occur through that will immediately stop it and from going to production. And then additionally, we receive all of our notifications for that directly in Slack. And how we do that, we have a very rigid schema for detection that we deploy that's managed within that Git. And Rob's going to provide the details on that schema in a second. And within that schema, we really have flags that set and determine whether it goes to development or production, and also determines which tables, as well as specific SQL queries that we're going to do for our specific detection. This is a visual representation of that detection engineering pipeline that we said. And really, what you see here is at the top. Like, we'll get that idea will be presented to our detection engineer. That detection engineer will go into that prototyping stage that we mentioned. They'll then commit a merge to Git. It gets reviewed by another detection engineer. Once that's approved, it goes to that automated pipeline, which runs out a series of test cases. And then ideally, as soon as those test cases pass, we immediately deploy those detections into production.
Cool. Yeah. So to talk through what our detection template looks like, this wasn't built specifically for Databricks. This is a multiple year project transitioning through our SIEM tools. We just aligned it with how we can deploy into Databricks. So just to talk through a couple of the key attributes that we have on here, we use everything in YAML. And we're able to, as Chris mentioned, just really make sure that it's a smooth process from defining the detection to then deploy it up. So to talk through some of the items on here, I'll start with the title and description. Really, title and description for us is like when an alert is sent to our case management tool, we want to be able to know like what is the context. So what is the alert title like that's coming in, but we want to also have some variable pieces of that as well. Like if you think about it from a user perspective, we want to know, hey, add the user in there. What is this IP address that's popping? We want to know that's in there. So titles and descriptions, we've built it out so that it's variable. We can wrap whatever column we want in a column statement. And then we know for a fact that when those alerts go off, we're going to take the values from those columns and then inject them into the title and description. The next piece on there is the identity and asset tables. So for both our real-time detections and our scheduled detections, we've also built out tables that house all of our identities across our environment and then all of our assets across our environment. So what this means for us is just really adding additional contextual data to each one of our detections and each one of our alerts. So whether it's like an in-stream join that we're doing in real time in the structured streaming, or whether it's we're running a scheduled query and we're joining on those tables, we know that downstream, when we have the contextual data, we can pull, like if a user set off an alert, we know the additional context of that user that we may not actually be capturing from those upstream systems. Same with the assets, like if an asset or a host name, whatever it is, sets off an alert, we know that we can then additionally add the full context of what we're capturing from that asset. A few other items, the key one here is SQL search. So this section of the template is really where we define like the criteria of the alert that should be going off. This is where someone can do joins, whether it's from other lookup tables that aren't our identity and asset tables. They can also add the where statement of the criteria that we're doing. The source table as well allows us, and with new features in Databricks, we're allowed to now stream from views. So whether it's a collection of multiple tables or it's a very complex query that we put into a view, we're able to now deploy real-time and scheduled detections. And really the SQL search there is like, we're looking for this specific criteria to set off an alert. Now we've seen it, send off an alert. A couple of the other ones there that you'll see, and really tying back to our guiding principles, is the compute side. So every one of our detections is deployed on an individual compute cluster. And as you can imagine, some of our data sources are much larger than others. So we really wanted to make sure that we had the flexibility and the accountability of the detections to say, hey, when we have a super large data source, we can scale out compute. We make sure that that detection runs on its own independent compute. And if for whatever reason it fails, it doesn't take down the rest of our detections. And then additionally there, right, if we have a really small data source, we can keep the compute low, keep our costs low, and make sure that we're not oversizing. The last piece on there is that metric section. So what you see of observables. So adding back to just really making sure that wherever we're sending this alert downstream, we want to make sure that we're adding whatever context we need, and we're providing our incident responders with all the context they would need in one pane, so that then they don't have to go into multiple other solutions and try and find that data. So we've allowed, for example, we have a couple of different supported observables. In this example, we have IP. So for a data source, we can include all of the IP addresses in which are popping as part of our alerts. And we take those values and we parse them out into JSON and make sure that we're passing that data downstream into our other automation tools and platforms. So next slide, just to talk through what our alert tables actually look like. The schema is much larger than this, but just to call out like tying it back to some of those template items that we were talking about. So alert title, alert description, right? We have our fixed fields, we have our fixed strings as part of that, But additionally, we're making sure that we can take those variable items and add them into our title and our description. Really, it makes sure that we don't have the same title for every single alert that's going off, and we know like this happened to this user, this happened to this asset. Same with descriptions, really a more descriptive description that we can then add more data into. The next one on there is the alert query. So for every single alert that goes off, we build out this alert query string that is also passed down. And what this does is it allows us to specifically look at every single event that triggered our specific detection. And for a multitude of reasons there, right? Detection engineering, you want to know like, okay, I've tested, I've deployed. Maybe there's not events specific to like, hey, I can find these events that are happening. Like some alerts are very rare, and we may not have events. So we want to make sure that if this alert goes off, we want to go back to that source table and we want to see those exact events that are triggering our alerts. A couple other items there, like we add timestamps, dates, those kinds of things with our date partitioning. So it's easy for incident responders to ultimately just copy and paste this SQL into SQL Workspace or into a notebook, run the query, and it'll immediately retrieve those specific events that set off that specific alert. And then that ties back to we store our data for a long period of time. So if 5 months down the road, right, we have an incident that comes up, we've had alerts in the past, we know that we can take this query at any given time and we can run it and tie back those events. And we can specifically see those events and when they happened and what happened in that context. And then the last column on there is the observables. So as I mentioned, we take all of the observables that we put in that metrics section, we take those, parse them out, put them into JSON, and then we're able to add those into our threat intelligence tools, our case management, and ultimately take all of these alerts that we have and tie them back together, whether that's with specific IPs, URLs, whatever we may use, to ultimately tie those alerts together, tie those cases together, and give our incident responders the context and relationships between different items. So I'll pass it to Chris, and he can talk a little bit about our response.
Yeah, so what we did is we built this extremely resilient system that sent us a large quantity of alerts, and we really want to think about what we would do next. And what we were finding is that really our commercial off-the-shelf SOAR applications that we're using weren't able to hit the speed that we were actually sending alerts or at the scale that we were sending alerts for it. So we really took a step back and really wanted to focus on what our guiding principles for response are. So our three guiding principles that we followed were scalability, context, as well as reliability. So we wanted to ensure that we could scale the system and accommodate the growth of detections that we have as we bring on additional use cases or bring on additional use cases or data sources as well. As we mentioned earlier, in 3 years, our data growth was 150 gigs to 10 terabytes, and we're expecting to continue to grow at that volume. So we want to make sure that this response system can scale at that growth as well. We also, when it comes to scalability, want to really think about modularity. We want the system to be event-driven and allow us to take those different events that occur and take those modular pieces and reuse them so we don't have to write the same thing over and over and over again. Now, when it came to context, right, you hear us talk about ECS, standardized data taxonomy, for the data sources that we're bringing on. We also want to take that same approach and apply it to detections, and we align to sticks. So that's why it's so important to parse out those observables. We can then take those observables very easily, create a sticks object, and send it to the downstream system very easily. We want to understand what our detection picture looks like for our environment. As we mentioned earlier, we have a very large enterprise environment, very large software environment, as well as a very large manufacturing environment, which cybersecurity, there's a lot of different MITRE attack frameworks that cover each one of those. And then we have a lot of external teams that provide very good context that help us make decisions on whether we really need to do something about that event that occurs. And finally, when it comes to reliability, like alerts need to be prioritized, whether that's say malicious alert or potentially an operational alert that something's not working as expected. And then we need very little downtime. The system needs to be extremely fault tolerant. So really want to just recall on trails from a high level perspective and cover it really from left to right and pick off where Rob had left us earlier. But from left, we have our ingest table, which then flows into our refined source tables, which then we have two sets of detections, which are just our real-time detections as well as scheduled detections. And finally, those detections hit really two sets of alerts. So we have our CSOC, detection response team alerts, followed by our cross-team alerts that we mentioned earlier. So when it comes to automation, those are what those two alerts pick up from left to right. I think we mentioned earlier that we built this tool to automate it that's event-driven. Internally, we call that tool FIRE. It's our frontline incident response engine. It's primarily infrastructure as code, a series of Python, as well as different queues that will then route that data set to wherever it needs to go. And how we did that, we used sticks to, as I mentioned earlier, normalize the information from that alert to allow us to easily make those decisions from platform to platform. So like really decision number one, that notification hits the Slack channel. That notification may go to the CSOC team or may go to an external team like our IAM and networking team. They'll receive a Slack bot. They can provide a response that will then circle back to FIRE, hit OpenCTR, our case management platform, where then it'll be on the eyes of our CSOC team or cybersecurity team. Well, if that alert is extremely important, we may want to notify somebody right now. And that will then hit pager duty and pretty much wake up that team right then based off the context from those alerts or the context from that team. With that, I'll hand it right back to Rob.
All right, cool. So just to close it out, talk through, like we've built this platform, we've built the automation tool, kind of just talk through like what's next and some of the challenges that we're facing right now and where we want to expand in the future. And I invite anybody, if you've solved these problems or you're working on these problems, would love to talk about it. And we'll be here and definitely want to hear some ideas from everybody. But just to talk about a couple of them, really the first one is like dashboarding, whether that's from the executive level or whether that's from the analyst level. We want to provide a full picture of what's happening. And really, Databricks is now allowing us to do that. We're able to build out whatever modules we need, whether that's for our detections, a dashboard to see what's actually happening, how many alerts we're generating, or whether that's just data ingest or whatever else we need to look at. The next one, definitely can't do a talk these days without talking about LLMs. So one of our challenges that we're facing, right, is as we onboard more and more data sources, as we have more and more tables, as we have various items that are happening across the board, writing detections, knowing what data we actually have in our platform, we want to build out a chatbot that ultimately allows our analysts, allows anybody, whether it's internal to security or our partnering teams that we have that need to query our data, like where is the data, what data do we have, and what can I query for what I'm looking for. So definitely a big one there. And then we found tremendous success both contributing and using open source platforms, whether that's Delta Lake or whether that's our case management or some of our upstream data processing systems, really just across the board, like looking at this whole platform, whether that's leveraging open source systems or implementing them, we've found great success. So I think it's fair to say that we'll continue on that path and really look at like what opportunities are out there from community, especially in cybersecurity, of like what can we implement into our environment to help us make our jobs easier. So with that, I'll close it out and say thank you and appreciate your time, and thanks for coming.